Hello everybody, welcome to the course Phase Diagrams in Single Component and Binary Systems. This is a 12-week course. Every week there will be 5 lectures. Each lecture will span around 30 minutes or so. And in this lecture, what we will try to learn is how to read phase diagram. Not only how to read phase diagram, also we like to calculate phase diagrams. And when we try to calculate phase diagrams, we need to understand phase equilibria, and in order to understand phase equilibria, we need to understand thermodynamics. So, this course will be based on a strong ideation of thermodynamics, and that is what we will spend good amount of time on that, and we will try to evolve with formulas, and those formula will allow us to calculate phase diagrams. And once we calculate phase diagrams, we will be able to know many things about phase diagrams as well as materials evolution. Like what are the phases that can form under the influence of different system parameters like pressure, temperature, composition, as well as we can also calculate the fraction of different phases that can evolve in a phase diagram. And of course, we will cover only 2 aspects. One is single component, and in single component we will take examples of water as well as CO2. And in case of binary systems, though there are phase diagrams involving 3 component, 4 component, 5 component and multi component, but we will only consider binary systems. That means, it will consist of 2 components. In case of binary, we will actually stay in the condensed phase system. Okay. Condensed phase means we will cover solid and liquid, but in case of single component we will cover even the vapor phase. Fine. And when we go along with the course, we need to know equilibrium concept and how we relate different phases under equilibrium, and then we will try to understand different phase diagrams in binary as well as single component. As we have talked about single component, but binary there are different types of phase diagrams like eutectic, peritectic, eutectoid, and there are many more. Those are complicated ones, but we will stay within the gamut of these 3 major phase diagrams: eutectic, eutectoid and peritectic. Why? Because one of the major engineering systems is iron carbon system, which also finally leads to steel, which is a major engineering component. So, that is what we will try to understand iron carbon phase diagram, and in iron carbon phase diagram we have these 3 important phase diagrams. Okay. So, in fact, we will learn those reactions, eutectic, peritectic and eutectoid reactions. So, let us start our course, and at the end of the course we will definitely learn quite a lot of phase diagrams, quite a lot about the phase diagrams, and definitely we will be able to calculate and also understand the kind of informations what we can snatch out of phase diagram. At the same time, with the help of some practical examples, we will try to link phase diagram information with the materials development. So, let us start our course, which is phase diagrams in single component and binary systems, and hope we will learn together. Thank you.